Hello ladies and gentlemen, in this video we are going to be looking at the Interpreting Solubility Graphs worksheet. Alright, so the first question, you had to define solubility. That is simply the measure of how well the solute can dissolve in the solvent. Okay, remember your solvent is what you have in the larger amount. The solute is what goes into your solvent. Right, so that is the answer actually to question number 2. So we were asking what is the difference between the solute and the solvent. And then for question number 3, why is water the universal solvent? Okay, so water, if you recall, we think about our Mickey Mouse for the water molecule. The ears represent the H's, and then the face represents our O. Okay, so there's our Mickey Mouse. The H's are the positive part of the water molecule. The O is the negative part. Now this is all related to electronegativity. Remember, these are all being shared. So here's your H, here's your O, here's your H. Okay, there are 2 lone pairs on that oxygen, creating this negative part of the molecule. So when we're thinking about water and why it's polar, it's because the oxygen is hogging the electrons, creating that polar end or that pole. So because we have this positive and negative component to the water molecule, it can attract itself to any ionic compound. So for example, if I have sodium chloride, sodium is the positive part, chlorine is the negative part, so the positive part of my water molecule is going to be attracted to the negative part of that salt. So then it's going to take this off of the compound. So it's almost going to like pull it off, and that's going to be what dissolves our sodium chloride in water. Okay? All right. So what are the 3 factors that affect dissolving? Temperature, agitation, which is the same thing as stirring, and surface area. All right, so then we're looking at all these graphs. So how does solubility change with temperature? So looking at my graph here, most of these are solids. So we can see that as our temperature is increasing, my solubility is also increasing. It's going up. Okay, so that would be a direct relationship. Now, what about a gas? So we have NH3 and then also this compound here. So what do we see happening with this line and with this line as our temperature is going up? You'll notice that it's going down. Okay, so that is what we would call an inverse or an indirect relationship. Okay, which salt is most soluble at 50 degrees? Or which salt can dissolve the most solute? We're going to find 50 degrees, and then I'm going to see which line is the highest. So as I go up, a lot of students will pick this one here, but if I go all the way up, I can see that this salt, actually, if I extrapolate it, that one would have the highest solubility. So my answer is going to be Ki. Now, which salt solubility is the least affected by temperature? Sodium chloride over here is pretty flat. It's not changing really at all. So that would be least affected by temperature. All right, for this next part of the worksheet, you were just supposed to find the data points between the grams and the temperature, and then locate it in relation to the line. So if I find ammonium chloride is right over here. if I find my data point of 70 grams and 70 degrees Celsius, here's 70 degrees Celsius, here's 70 grams. So when I have that intersection point and I look at where that's at in relation to my line, I can see it's above the line. So that would tell me that it's super saturated. Now the next one, we have 20 grams of potassium chloride in 100 grams of water. Remember, we just ignore that. So we're looking at 20 grams of potassium chloride and 40 degrees Celsius. So I'm going to find 40 degrees, 20 grams, that's my intersection point, and I'm going to be comparing this to this line here for my KCl. So this point is under the line, so that tells me that it's unsaturated. And then the last one we're looking at is 80 grams of potassium nitrate. I'm going to ignore that at 50 degrees Celsius. So I'm looking at this number with this number. So 80 grams is on my y-axis, 50 grams is here. When I plot that point, it's directly on the line, so that tells me it's saturated. Okay, now for the last ones here, this is where we are looking to find either grams or temperature. Okay, so question 12 says, how many grams of sodium nitrate will dissolve in 100 grams of water if the temperature is 50? So I'm looking at NaNO3. I'm going to find, I'm not worried about this. Okay, just put that in parentheses. I'm trying to find the grams. So my temperature is 50. So here's 50. I'm going to go all the way up until I hit that line, and then I'm going to read over. And that's going to be about 111 to 112 grams. Okay, how many grams of KBr will dissolve in 100 grams of water at 75 degrees Celsius? I'm going to find 75 degrees Celsius about here. I'm going to go up to my line, make my point, read it over, and that's about 92 grams. For question 14, I'm going to go 50 grams of ammonium chloride. Here's my ammonium chloride. Now pay attention, it's not this line, it's this line. So if I make my point, here's my 50 grams. I'm going to go over to my line, and then I'm going to read it down so I can see what temperature that is. And that's roughly 45 degrees Celsius. And then for question 15, at which temperature will 70 grams of KBr dissolve? Ignore in 100 grams of water. Here's my KBr. I'm going to find 70 grams on my y-axis, go over to my line, and now I'm going to read down, and that's going to be right here, so it's in between 70 and 80, so it's going to be about, let's see here, I messed this one up, this one is not 30, okay, so this one's actually, let's see here, here's my KBr, so I'm going to do 70 grams of KBr, here's my 70 grams, oh there we go, I was looking at the wrong line, so here's 70, there's my KBr, now I'm going down. So there's my 30 degrees Celsius. Okay, so this is, again, you got to take your time. I just messed up there as well. So you want to make sure that you're looking at the right compound and you're reading either your y-axis if it's for grams or your x-axis if it's for temperature. Okay, one more question to go. Now this one has you trying to understand solubility of a gas. So a fisherman is trying to explain to his grandson why it is optimal to fish in the morning rather than the afternoon. Using the solubility curve for oxygen and the temperatures on the thermometer, construct an explanation for the grandfather to respond to his grandson. Okay, so we can see because it's a gas, as my temperature's going up, my saturation of the gas is actually going down. So if we're looking at the morning temperature of 60 degrees versus the afternoon temperature of 92 degrees, the morning is cooler, so that means there's going to be more oxygen dissolved at the surface of the water, so the fish would be more active. Okay, so a good response would be from the graph. We can see that oxygen solubility is higher when the temperature is colder. Given the morning temperature is 60 degrees, this is cooler than the afternoon. The fish have more dissolved oxygen and are more active in the morning. That would be a perfect response. Okie dokie. All right, ladies and gentlemen, hopefully you're feeling better about reading and interpreting solubility curves.